This is a two-part question, the first dealing directly with this acid-base reaction, and it asks you to identify the conjugate acid-base pairs. An acid is a proton or hydrogen cation donor. That means the reactant, that is the acid, must have an ionizable hydrogen available. Since water is the only reactant which has hydrogens, it's the only one which can donate a proton, so it must be the acid. Thus, the nitrite ion must be the base, because it's not the acid. The conjugate base of an acid is defined as the particle that is left after the acid has lost one hydrogen. Looking at the products, it's obvious that the hydroxide ion must be the conjugate base of the water. The conjugate acid of the base is the particle created when the original base has accepted the hydrogen ion. So it should look like the original base plus one hydrogen. So here it's pretty obvious to see that the nitrous acid must be the conjugate acid of the nitrite ion. So the conjugate acid base pairs are water and hydroxide, and nitrite and nitrous acid. Part B refers back to nitrite ion, but doesn't really reference the reaction, so we're going to ignore that. Nitrite is a stronger base than hydrogen oxalate. Based on that, which acid should be stronger, nitrous acid or oxalic acid? And then justify your answer. You have to give the reasons. The first part of the question, oxalic acid is stronger than nitrous acid. Why? The stronger the base, the weaker the conjugate acid. When you compare two bases, the stronger base will have the weaker conjugate acid. Nitrite is a stronger base than hydrogen oxalate. Thus, the conjugate acid of hydrogen oxalate, oxalic acid, must be stronger than the conjugate acid of nitrite, nitrous acid. You have thus justified your answer.